Hi guys, my name is Arturs and today I'll be talking about the one and only way of designing Java applications. The topic is, well, you can see my handle. Okay, never mind. Oh, that's too much. Yeah.
Now?
1, 2, 3.
Is it good?
I think there's an echo. Is there an echo? No. I hear echo.
Just enjoy it.
Yeah, will do. I love echoes. So, and hearing my voice, but it's okay. So, the topic is especially controversial because I don't think that there is one and only way to design Java applications, and the point of presentation is to...
Is it good? You talk now.
Okay, so the point of presentation is to explain that in any case, each team has to decide on their own one and only way, and it's not universal to all the teams, but in one team to collaborate and work together, you have to have one way. And so we also had a lot of struggles in our team to find our way, and we thought that it might be useful to share the journey we had. And this presentation is less about answers we got and more about questions we asked and the problems we had and arguments we used. So this should help to have discussions in your team about the same topics. And it's possible that you already know all the answers, and this will help you in no way, but if at least one person will have some meaningful discussion in their team, that's a win in my book. So, without further ado, this is the outline, and basically we look at the two ways we thought about doing APIs, or rather two ways we thought about doing APIs, 2 ways we thought about doing packaging, 2 ways we thought about doing exceptions, 2 ways we thought about doing tests, and just a little list if you'll have time to just look at the frameworks and libraries we thought that are just necessary in every project. We just add them everywhere, so maybe you'll see some name and use it at your discretion. So first of all, the APIs, REST versus remote procedure call. Well, first of all, the REST I'm talking about is not RESTful, and remote procedure calls are not remote procedure calls. So the point of this is that these are like more like styles, and the names are not really precise. So I'll explain why REST is not RESTful in this case. And remote procedure calls are useful when you use them as some binary calls or something. But if you do an HTTP API and you try to emulate remote procedure calls, that's bad. And well, it might be good for you, but I'll explain what are the pros and cons. So first of all, the difference in these two styles is that first of all, REST uses HTTP verbs like get, update, get, post, put, and delete. There is no update, I'm sorry. Patch and stuff to do things. So these verbs define what will happen. And the API should be traversable and discoverable. It should be intuitive in that sense. And I'll talk about HTOAS a bit in the next slide. But basically, that's what I mean when I say REST API. And then there's the remote procedure call that I put on the other side of the battle. And it uses URI fields as actions. And well, it's not that intuitive, so you have to remediate it with your consumer to say, hey, you have to call this, so it will work that way. And well, first of all, let's look at HTOAS, which basically, to have a RESTful API, you have to have this thing. HTOAS stands for Hypermedia as the engine of application state. That's a mouthful. So what does that mean? Basically, if you look at Hypermedia, it's just media in the hyperspace. We can just say that those are hyperlinks, basically hyperlinks. Hyperlinks as the engine of application state. What is application state? Application state is basically the state of your domain entities, the changes. If you delete an item, it's a change of application state. If you add item, it's also a change of application state. So the engine of application state, it means that it's something that facilitates the changes in your domain entities. And Hypermedia as the engine of application state means that basically hyperlinks as the means of changing your domain entities. That's what it means essentially. And why is it important? Even though I don't advocate using it in your APIs, But to have a RESTful API, it's not necessary, and it's good to think about HeyTOAS when you define your REST API, even if you don't use it. So basically, this is one of the HeyTOAS is just a theory, but this is one of the implementation, which is how. And as you can see, when you request, this is a response for a /orders call, a get for /orders. And first of all, you can see that it has a links block, which describes the URL you have called and the URL that will be, well, in that case, the next page. And then, as you would expect, when you get orders, you have some items, basically orders. And they also have a links block, which would also contain a link to itself. This is an order 1, 2, 3, obviously. And a link to some arbitrary basket or whatever. And you can see that using this thing, you can just navigate the URL, the structure. You can be like, oh, is it an order? Oh, I want to see the basket and such, and you would follow those things. And you don't have to have it, but just keep it in mind when you design your REST APIs, because this helps to design it in a way that is intuitive and you can follow it through, even though you don't have this exact thing. So now let's look at some. That being said, now let's look at how you would do some CRUD operations with something I call REST, which is not RESTful, and something I call remote procedure calls, which really is not. So first of all, how do you create items? Well, the easiest way is if you want to create in REST, you want to create an item in a collection, you do a post, like you would post something to a message board. So you post some item to /orders to the whole collection, you get a 201 created status, and you would get a header with the location of the new item. That's how it should be. And the other option is to put, if you don't know the ID the item will be getting, you would do post. If you do know the ID, you would do a put to the exact URI. And the way put works is you say, I will put it here, and next time you get it there, it should be exactly what you put. So when you put this thing, you already have ID there, and it will just respond to 100 or 204 that was successful. The other way is remote procedure call, and in this case, if you want to create something, you can imagine any way to do that. You can use some query params or something. You can use post combining with query params. You can do a lot of different things. And first of all, you have to guess, like, should it be create, should it be add? You don't know. And the response is also kind of unknown in this situation. So since it's a remote, since it's just a call of a function, the function can do anything, and it can return something, not return something. You never know. So in that sense, it's more predictable to use REST or REST-like API. Then in this slide we do read, and I put them both in the same box because I don't think it's possible to fuck up get. I think that whatever you do, even if you do it wrong with remote procedure calls, you would still get it right. So the way it works is that if you want to get a collection, you do get on collection, and you get a collection of items with 200 OK. If you want to filter, and basically what I wanted to show there is that if you want to get a collection that has nothing, you still get 200 OK, an empty collection. If you want to get one item, you go to collection/ID, and you will get 200 OK and the item without the collection, obviously. And then when you get something that doesn't exist, you get 404 not found because the path leads nowhere. So that's pretty clear. I think that even guys who misuse REST would still do this properly. Now update. Again, you can put stuff. It's exactly the same as in the first slide, and then patch. Patch is something that is not standardized at all. Here I show the JSON patch content type, which is basically an array of objects called something like operations. So it has an operation like if you want to change the amount of the entity orders 1, 2, 3, you just operation replace. You put the path, so it would be /amount because it's the first field in the root, and then the value that you want to update, and you get 200 OK or whatever. And on the other hand, again, remote procedure call, whatever. You can imagine anything, and it will just work, and you would never know like what's the proper way. And it can return whatever, because it's just a call of a function. It doesn't make any sense to predict it. And again, deletion is super easy. You either you say delete path of something, you either get 200 OK or 204 no content if it's immediate action, and you get 202 accepted if deletion is accepted for future but is not immediately done. again, remote procedure calls, no one knows. So, to sum it up, REST provides REST-like but not RESTful APIs, provide intuitive design, because you always know there's a slash collection with items. If you add ID in the end, you will get the exact item. If you add question mark and query param, you will get the filtering and stuff like that. It's super understandable, even without the ATOAS. API longevity, well, the designer of REST, I don't remember his name, he defined that REST should promote longevity, that most of APIs are built without thinking on future prospects and just on today's problems. And REST promotes API longevity because even in, like, I don't know, 50 years it will be obvious you go /entity/ID to get the item, rather than some procedure code that you've invented that might change its signature. That it's hard to maintain, add stuff, and the like. And REST is super modular. And another thing of modularity is layered architecture. And an easy example is caching. Basically, the fact that REST is so predictable, you can add some abstractions on each step. So for instance, if you have a get, you know that get doesn't change anything, and that get would return the same thing if nothing has changed. So you can just add an intermediate layer that if the request goes from the client and gets on some proxy, and the proxy already has your response, it can just respond because it knows that get shouldn't change anything, and it knows that nothing has changed on the backend. So it will just bounce you back the answer, and you would not be the wiser. You wouldn't know that they didn't go to the actual server, because REST allows a lot of abstractions in that sense. You can have some balancing, you can have some header magic that would allow to do whatever. The point is that predictability of REST allows you to do some layering like an onion and get some efficiency there. Well, the cons are it's hard to kickstart it. If you add some endpoint like /order/ID, you already have to think, what if user wants to delete? What if user wants to put? What if user wants to post? Whatever will happen with that endpoint, you already have to think about it, and it's sort of hardish to start doing that. On the other hand, remote procedure calls has one pros. It's super easy to start. You do whatever you want. You don't have to think on how you will name entities. You don't have to think about anything. Those are just like methods. So you put any params, you do whatever you want. On the other hand, it will be harder to maintain in future. It will be harder to traverse and operate on this thing because it doesn't help like ATOAS does. You can't really imagine what would be some specific stuff. And well, it's hard to layer an abstract because the call, does it change data? Doesn't it change data? Can you cache it? You never know. So it's harder in that sense. Next topic. These topics are just like put together like this, so there won't be any transition. So package naming. At first, when I started programming, I would never understand when to use singular and plural. And at some point, I just got the answer. And people sometimes still ask, so I decided to include this slide because it seems pretty obvious, but I mean, if someone is still struggling, maybe this will help. So basically, you use singular when you have one domain entity and related stuff. So basically, when you have everything related to one thing, and that would be like item DTO, item factory, item whatever. And on the other hand, if you would use plural when you have a lot of similarly typed items, or a lot of different variants of the same item. So like good item, no op item, simple item. Those are all items. Those are not all item related. Those are all items, and so they will be package items. That's something I think is pretty straightforward and doesn't cause any debate. This thing though, might end. First of all, I did it incorrectly. So in this example, on the right column, it should be domain and then DTOs and factories, as I said in previous slide. But I kind of, well, no consistency between slides. Anyway, one way to do it is sort of domain-driven packaging, even though it's not real domain-driven, because you would need some other like value object and stuff like that. All in all, domain-driven would be when you would put items that work on similar entities, you will put them in similar packages. On the other hand, you would put similar items into well, basically it's the previous slide, but with like more items. So you would put similar items to similar items, but not items that work on the same entity, if that makes sense. And so you would ask, why is it important to do it domain-driven rather than put controllers in controller package, DTOs to DTO package, and stuff like that? Well, basically, the simple and shortest answer you can have is it allows to use package private access modifier. And when I didn't understand domain-driven design, I was kind of, yeah, but it's useless anyway, so why use it? Why is it important to use that? And after I started seeing the benefits, I realized that actually package private modifier allows you to do a lot of interesting things, a lot of control over your code, and it's no wonder that it's the default modifier in Java, because it's just so good. And well, the first thing, how that would work, if I would for some reason want from the bar factory to request full object, I would get that, hey, it's not public, you could use it. Well, that's obvious, but the point is that why should I in bar factory do something with full objects? It's actually the full domain entity, and I shouldn't access that. And there are a lot of reasons. Like, first of all, less coupling. If you can't use something, you won't use something, because oftentimes you would be like, oh, to implement this code, I need to call 3 services, and you would just, or like 3 repositories or something, and you would just do and call them. You wouldn't think about maybe I shouldn't call this method from this location. Maybe I should call some other intermediate method. So, and because you can use anything, you would use everything, and you would have this tight coupling that in one service you would inject like 10 other services which shouldn't be injected, and you should inject only maybe 1, and that causes a lot of problems in the future. Clean global scope, well, if you want to autocomplete, or just in any case, you would always want to keep your global scope cleaner rather than dirtier, because again, if it is in global scope, someone might misuse it, and something bad might happen. And you also just don't want to trash your global scope. Nor service bypass. The typical problem is when you have repository pattern, and you should always use a repository from the appropriate service, and then call a service from another service. So if you have like dog and cat service, and you have dog repository, you cannot use dog repository in cat service. You should use in dog repository cat service, and then in cat service use cat repository. I think I switched terms there, but the point is that you should never go through abstractions and through domain boundaries, and this will allow you to not to bypass the services, but always go to appropriate service for appropriate stuff. No mindless reuse. Typical problem when you see that some library is not used, you delete it from POM or whatever, and then in some place in your code some exception becomes red, and you're like, why did this exception break? And then you find out that the dependency you deleted had a dependency, and it had a dependency, and it had an exception, internal exception that wasn't package private. And some guy in your code was like, oh, I have like an item domain entity, and now I have a situation when item is not found. Oh, let me look if there already exists an item not found exception. And it's in some random framework somewhere on the other side of the world, and he's like, yeah, I'll just use it. And next time you delete the dependency, it just breaks. And that's awful. And so, no mindless reuse. If you can't see it, you can't use it, you cannot make mistakes. And easier to search for related items. This is debatable. Basically, you open a package called bar, and everything that is related to bar will be there. You can just use it, and it will just work. So, next topic. Checked versus runtime exceptions. First of all, a small reminder. What's the difference? Checked exceptions, extend exception, unchecked extend runtime exception. And if you want to use, if you throw a checked exception, you have to either declare it or try catch it. And otherwise, you can silently just move forward, and it will just float somewhere else and bring a surprise to the programmer. And there's a super debatable thing that well, basically, it's important to state this because it will help us think in the next slides the way we thought when we were developing this. But in the end, I'll give you a spoiler that this is not true, but basically as a statement for the next slides, all business logic exceptions should be checked. And to just explain what's the thought process here. Two, I didn't know how to call it, but I called it rules of domain abstraction. Basically, first thing is when you get some data, get some domain entity, there are three options what could happen. You can either get something which is nothing, and get a problem while retrieving data. So it would always be these three options. There is either an item, an absence of item, or a failure. And another rule is that whenever you do, there's a structure where you first call service A. Service A, to fulfill its request, has to call service B. Then service B has some failure. It throws back a fail B exception. And service A should never expose fail B exception to the caller of it, because person who was calling service A was calling for a get A. It doesn't care if what happened underneath, if there's a database exception, whatever. It doesn't care. It just wants its A. And the fact you can never allow B to float out of A. It's a bad practice, because this way you will have handling database exceptions in your controller, which is awful. So now that we've got this out of, let's look at the example of perfect exception stack. This is something I've invented, and I thought that it's perfect. It handles all the cases, and next we'll see that it doesn't work. But just to give you some thought process and maybe something to discuss about. So first of all, we have a order domain entity. We have an order package which has everything related to the order. Now, first of all, we create a public abstract exception, which extends exception, which is a checked exception. And it has no public, it has package private constructors. And important things here are, first of all, it's public. So it means that anyone, anywhere in your code can handle this exception. But it's abstract. This exception will never be instantiated. It's just like a blueprint for the real exception. And you can always handle it, but you cannot do anything more with it other than just handle it. You cannot create it, and you cannot override it. You cannot create an implementation outside of the original package, because the constructors are package private, so we won't be able to build it, and it is abstract, so we won't be able to do new on it. Now you extend it with, for instance, order not found exception, which is just some concrete exception for some concrete situation. Order was not found. What happens here is that it's a package private exception, and also the constructors are also package private, which means that no one ever outside of your package will be able to build it, because why the hell anyone ever would be able to build order something exception other than order package or things in order package? It makes no sense, because if something is working with orders, it should handle all the things that happen with it. And so it extends the order exception, and you can instantiate it inside of your code. And so the way it would work is that, for instance, it's a get order that would either return an order or throw an order not found exception. And you can see the pattern I said. You either return something, return nothing, or return a failure. You can see all of this in the signature. So you return an order. It means that you can return something. A null is also an order, so you can return nothing. And you can also return a failure, because it throws order not found exception. So it's possible that the order will not be found. In this way, the signature of this method is fully compile time checked, and it explains everything that happens in this code. And for instance, if you want to use it outside of the intended package, so if you want to use this method, this is a public method, so you would normally put it in a service, and then in some other package you would want to do something with orders, do stuff with order. So when you would use it, you would either have to declare that it throws order not found exception, because that might happen, or you can try catch it. But if you notice, you can only catch the order exception. You cannot do custom logic based on what exception did order service or order anything throw, because that is not your business. How does order functionality work? If you're outside of package, you shouldn't care. You should be just like, I want an order. Oh no, something went wrong. Whatever went wrong. I can't get an order. I have to live with it. So order exception, you can only handle the common thing. You cannot handle some specifics. So why does it fail? Well, unfortunately, with lambdas in Java, you can't have unhandled exceptions. You cannot rethrow them. You cannot do anything. you have to try catch them, and it's just awful, breaks everything, looks awful, and it just put me in a giant depression because I thought it was a bulletproof theory, and unfortunately it just doesn't work. So what you have to do is either try catch, or you can throw another exception. You can throw a runtime exception, but who cares about runtime exceptions? You can ignore them, and you wouldn't be punished by compiler, so it means nothing. And well, another thing is that there is no fail flow, and so the answer to what do in this situation, we've introduced checked exception, they don't work. The answer is don't use checked exceptions. So you'll be like, why did this guy tell us all this great theory about checked exceptions if he says that you shouldn't use them? Well, basically the idea is that what's important here is that what we were fighting for. We were fighting for the maintenance of the three things. You either get something, get nothing, or get a failure. And if you use, let's say you can use optional, or you can use streams or stuff like that. Well, if you look at optional, it has no exception flow. You cannot do like on error or something along those lines because well, it doesn't have it. So the answer here would be, yeah, you can do something similar of what I've described with checked exceptions, make them unchecked, and then use RxJava or Reactor because they have on-error methods, and it would work there pretty natively. So you'd have onNext, which would either return you something or nothing, or on-error, which would allow you to handle exceptions. So basically my answer is a non-answer. Unfortunately, my beautiful theory died, and I still don't know what to do with it. Next thing, this is a pretty short one, unit test versus functional test. We had a lot of debates which test to write. So basically there are two. This is like a giant line. On one side there are unit tests, on the other are functional or integration tests, if you might. So maybe testers will kill me because the naming is incorrect, but in any case, unit tests test the smallest possible unit of code, and they test they're super close to the code, and so they're super fast, and also they're highly code dependent. So if code changes, test breaks immediately, just immediately. And they're super bound to the code. So kind of if the implementation changes behind the API, it shouldn't sort of impact the code, the tests. But in unit test case, it will. And in integration test, basically it's the whole other side of the spectrum when you try to plug everything in and you test as big part of everything as you can, and it's basically dependent on the API rather than code, so the contracts are what's important. And if the implementation breaks, no one cares if the code still performs what it has to do. It's kind of the right object-oriented way, if you may. And well, the issue here is that they're super slow. If you need to start like Spring Container with some database in Docker, it would just take minutes, and tests shouldn't take that long if you want to run them on your computer like every build or something. So these are two sides of spectrum, and what we found out, first of all, that we don't know on which side of spectrum we want to be, but from the tendencies we had, I might say that if you have a lot of custom logic, like you have a lot of complicated algorithms you've implemented, then it's likely that you would use a lot of unit tests, because unit tests will really test your code, and your code is the most important part. But if you are like us, where we less write some complicated algorithms, but more put random frameworks, put them together, take them in, like an enterprise development, in a sense. If you do more of that thing, then there's nothing to test, because most of the code is like automatically generated or built by annotations and stuff like that. It's more efficient to just use some functional test that will put it all together and just see if it works, because that turns out to be more efficient, and it sort of starts to make sense. It doesn't make sense to write a unit test for a code that will be generated. It will be generated properly, there's nothing to test. So, or rather, there is something to test, but it's not for you, but the person who implemented the generator. And as such, it's kind of a spectrum. You have to, there is no right answer here. You should have a mix of both, but which direction you lean on, I guess, will depend on how many custom code you have. Now, the sort of last part, frameworks and libraries. So these are the frameworks that we found out to be like standard de facto. If we create a project, first thing we add these things, and these are just, well, if you haven't heard of them, then I just shortly explain. The Lombok is a thing that allows to remove a lot of boilerplate code. It generates two strings, it generates getters, setters, stuff like that. So you just add an annotation and you get a perfect class with a couple of fields and everything else is generated, which is similar to what Kotlin does. So if you've seen stuff in Kotlin, you most likely will like this in Java. And mapstruct, which allows you to generate mappers between one classes. So the way we use it, like previously, you would leak entity object, you would return an entity object from the controller, which is bad. You should first map entity object to the DTO and then push it out. But creating every time a new DTO map, creating a method that would map the fields, it took so long time that you would be just like, okay, this time I'll just use an entity object, and this will lead to some issues. Mapstruct does that, all of that for you. It just generates the mappers, you just put some annotation and it works. So these two are just like, I put them inside of Java as a native library. It's just so good. And then OpenAPI specification, earlier it was known as Swagger, now it has a bit different name, but it was like standardized. So this is basically the API definition. I'm pretty sure that everyone who uses Spring saw it and uses it. And well, basically, first of all, it allows you to create contracts from your code. So you have a controller, and now it automatically generates the definition, so we can give it to anyone else, and anyone else can use your API. And then it also has some beautiful UIs to click around and see how the API works. And there are some other things which I will not explain, but in Spring there's actuator, sleuth, and configuration processor, which we always use. Makita, SRJ for tests, Flyway for database migrations, and test containers for actual test containers is an interesting thing. It actually allows you to launch Docker containers when you launch your tests, so it helps you with integration tests. You can, for instance, if you have a Postgre database and you want to have some scripts that work on the startup of your application, you would add a test container with Postgre. So anytime you would launch your unit test, it will start Docker container with Postgre, connect to it, work with it, and kill the container, and the test ends. So it allows you to easily do integration tests with any system you have to put up and then turn down. Like, I don't know, maybe even JBoss can be found in test containers, whatever. I guess that's about it. Thank you for your attention, and any questions?
Yeah, like in the beginning, for example, where you compared REST and RPC, it seemed a bit one-sided. So does it mean you give us the answer?
The point is that I tried to explain the complications of our way through showing our way. So I kind of lean towards our one and only way, and I kind of leave to make the decisions for you, but in the end there must be a reason that we chose this way to be one and only. So I kind of strongly believe in it. So I just can't be like super unbiased here. I mean, there's one good way and there's one bad way. How can I tell it differently?
Yeah, but okay, I get that. That's amazing. But putting yourself in the shoes of others, do you understand maybe why could someone think of using RPC? Any kind of benefits other than
yeah, I'd say that if you need something with a really slim specification, like you need to call, like why would you just use remote procedure calls? Basically, I would say that remote procedure calls most certainly have a use, because if you want to actually call a procedure remotely, it's perfect. If you want to just call some code that will do something and efficiently return back. But then again, my question to you would be, hey, why not use remote procedure call frameworks? Why do you use HTTP for remote procedure calls? If you actually need that, use that. Why use HTTP incorrectly? Because I think it's kind of incorrect to use REST or HTTP for that. But yeah, of course, remote procedure calls have their place. Inefficient and fast systems that have really narrow use case. But again, I don't see why you would use the HTTP overhead if you need something as efficient and as efficient.
What do you think about gRPC?
I I'm not sure I saw it, but I would imagine it's JSON for PC, no?
No. gRPC from Google, it's generated, it uses...
Doesn't it use bytecode though?
It uses protobuf.
Okay.
And it uses HTTP too. But if you have no experience, I guess...
Okay, yeah, it would be hard to debate that, yes. But I look at it. But I think that it uses HTTP.
HTTP too.
Yeah.
Well, it technically can go whatever, but standard also HTTP.
Let's do chit chat a bit later. Let's give time for.
Okay, sorry. Any other questions?
Okay,
That's
Pius and
our
Arturs,
chit-chat.
you can talk. Thank you very much. Chocolate for yours.